A system of two springs where the displacements are equal to each other is known as a parallel connection. The first system appears to be a snapshot of a parallel connection. However, without additional qualification or constraints, the system may undergo changes as shown and may not keep its parallel designation. A parallel connection may also be achieved by placing one of the springs inside of another. Since this is a parallel connection, the lengths and the displacements are the same. The force of the effective spring must be the sum of the individual forces to substitute them. When each force is expressed in terms of common displacement delta and the respective spring constants, the well-known result is obtained for the effective spring constant Ka. In this connection type, neither displacements nor the forces are the same. Instead, there are relationships we can utilize. Since there is no friction, the same tension is applied to the end of the springs. The pulley is massless as well. This means, effective force is twice the tension at all times. On the other hand, the sum of the spring lengths plus a constant fraction of the string length is twice the effective spring length. Again, by taking derivatives or subtracting equations at two different times, we obtain a familiar relationship between the displacements of the springs. As in the previous case, we arrive at an equation involving Kb in terms of K1 and K2. In this connection type, the forces are the same because the springs are massless. Sum of spring lengths are equal to the effective spring length. Again, by taking derivatives or subtracting equations at two different times, we obtain the relationship between the displacements of the springs. As before, we arrive at an equation involving Kc in terms of K1 and K2. In order to sort the effective spring constants, we note that K1 and K2 are given to be different. Kb is 4 times Kc, which means Kb is always the greater one. To check the relationship between Ka and Kb, we can look into their difference. A few steps of algebra reveal that Ka is strictly greater than Kb. Thank you for watching. Visit starleague.us for Physics Olympiad summer camps and courses.